So today we are going to solve the problem of the day for 12th Jan. So I have tried this solution, tried this problem. So the question is, check if the parenthesis string can be valid, right? It's a medium type of a question, and topics are string, stack, greedy. Okay. So the question is, a parenthesis string is a non-empty string consisting only of open parenthesis and close parenthesis. It is a valid if any of the following condition is true, right? Okay. uh, See, this is a question in which we are given a string s. We are given a string s, and s is a string consisting of open parenthesis and closed parenthesis, and we have also given a string locked. So what locked is? So let's see the example here, right? Let's see an example. Right, so we have string s and locked. So the locked means if any character or any parenthesis is locked, so that means we cannot change that character, right? So that means if the character is unlocked, which is 0, so we can change it, and we have to check if by changing any unlocked character we can make this parenthesis balanced, this string parents balanced, right? So as we can see, uh, we can change this. So the s will become, so this is unlocked, so first one is unlocked, so we can change this. By changing this, these will get balanced. Second one is locked, so we cannot change. Third one is unlocked, right? So we can change. So we will change. One second. Sorry guys, this is a I think this is a wrong string. Let me check it again. Wait. Right. I'll also paste it here. Okay, so 1 2 3 4 5 6, 1 2 3 4 5 6. Okay, 1 2 3 4 5 6. So this is unlocked, so we can change it. This we will change this like this. First one is locked, second one is unlocked, right? So we will change this, right? Okay guys, this is a wrong string. See, we have 1 2 3 4 5 6 7. We have a string of 7 parentheses, but uh, they are considering this like so string should be like this. Okay, so okay, we will check it again. They have given only 6 locks here, but the string has given 7, so this is a wrong example. They have mistakenly did this. Okay, so let's see now. So this is unlocked, so we will make it we will change this for balancing this third one is also unlocked, so we will change the third one also. So now this is a balanced string, so we can say that changing the unlocked characters, we will make the string balanced, so we will return true. So now the question is how to solve this, and what is the starting with the native approach. So what is the native approach? So what is the basic thing which we can do, right? So the native approach is how to solve this, right? So the native approach is we will okay, so the native approach is like we have 1, 2, 3, and 4. We have four characters which we can change. So we will change all the four characters, and we will check all the permutation and combination, and we will apply all the permutation and combination to the string and check if the string is a balanced or not. And in any case, if string got balanced, so we will return true, or the otherwise, if in any case string didn't got balanced, so we will return false. So the step is make all the permutations by changing unlocked characters. Now check each mutation and verify that check mutation that if it is a balanced. Third, if any permutation is balanced, return true, else false. Okay, so talking about the time complexity. So for making all the permutation and permutations, we have the time complexity of 2 to the power of n, right? 2 to so for all the permutations, for making all the permutations, we will check we so for making all the permutations, time complexity will be 2 to the power n, and for checking that the string is balanced or not, the n time complexity will be also be there. So this is the time complexity, specs complexity. For storing all the permutations, we have n into 2 to the power n. So as you guys can see, this is a very first thing which we can do in terms of programming. 2 to the power n is the worst time complexity ever, right? So of course we have to reject this approach. We cannot try this on coding. So can we do it better? Okay, can we do it better? STACK. So we can use stack. Okay, can we do it using stack? Can we make it better using stack plus a DP kind of a solution, right? So what a thought came in my mind. Okay, we have to take this one because this is a wrong example. A thought came in my mind that can we, so this is an unlocked string, right? So this is an unlocked string. So we have a array of stacks, right? Stacks is nothing but an array. So this is so let's make this 1 and this for the sake of this example, right? Or else leave it here. Okay, so in this array of stack, right, this is a unlocked string, so there can be a two possible things here. One is this, one is this. So the one is this. What is this, bro? One is this, and the other one is this, right? So we have two possible cases here. Okay, but starting from the close parenthesis, so we will ignore this because we will reject this case. So starting from close parenthesis is not allowed, so we will reject that case. Now this is a fixed string, so we will append it, and and if any string got balanced, so we will remove. Okay, now again uh, we have a open parenthesis with okay guys, leave. Let's change this example like this and make it 1. Okay, so in the very start we have uh, we have a open parenthesis, which is fixed. Again we have a open parenthesis which is also fixed. So we have only one stack here. I represent a stack using a string. So we have only one stack here. We cannot make any other stack, we cannot make any other combination. And this is a unlocked string, right? So we can make two stacks, one with considering this as a open and one with considering this as closed, right? And this is also a set, not a stack. Okay, so one with this closed, and if anything get closed, anything get balanced, we will remove. So we have only two options left. We have now two options left. Okay, so by this, and this is closed and fixed closed, so we will close this. So we will remove, and we will close this, and we will remove. So we covered till here, right? We have two options. Okay, now consider this. This is a fixed sorry guys, we still make a mistake. So let's say we have this. Okay, this is fixed, so make it like this and make it like this, and this is a variable. So we will consider it once open. So we will make open, and we will consider once close. So we have earlier this is string, so by closing this will remain 2. So we have already 2, so we will not add this, and we have still this, so we will so by closing this will remain a empty string, right? We have done our iteration, and if in between this we got and in the end of the iteration, if we got a empty string, right? If we got an empty string, so that means we will return true, else false. Okay, so this is of course a true, so we will return true. Discussing about the time complexity. Time complexity is we are doing iteration here 1, and we are doing some iterations here, right? So let's say this is also a, so we have, let's say, and all the unchanged, all the what I can say, all the unlocked ones. So we will make a n strings here. So that means the time complexity is n square. The space complexity is, of course, for making this, it will remain n, right? Now can we eliminate this? Can we eliminate O of n, or making so n into delta for storing this? So I will consider this n is because this is also a string of length n, some kind of n, so this will become n square again. So can we optimize this? I am doing some kind of optimize for reaching the best optimized solution, right guys? You have to think like this. Optimize the solution as far as you can do. So we don't have to use stack here, so no stack, right? What we will do is we will consider open parenthesis as +1 and close parenthesis as -1, right? So again, look at here, we have to do similar thing, but with open parenthesis as 1 plus 1, and uh, so we will make set of integer right. So this is now 0. We have an open parenthesis which is locked, so this will become plus 1. Okay, we have again an open parenthesis with locked, so this will again become plus 2. Now closed parenthesis which is unlocked, right? So what we will do is we will consider it as a open ones and closed ones. So with open this will become plus 3, and with closed this will become plus 1. Okay, so we don't have to add plus here. So we have two cases here with 3 and 1. Okay guys, so as you can remember, you can go back in this video and check that what 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 is the set when we are iterating on this one. So you will find that we have one this option and one this option, so you should have this. So that means we are doing good. Now we have a fixed close. So fixed close means we have to remove the parenthesis from both the options. So this should be like this. We have a fixed open here, so this will like 3 1, and we have a unlocked. So while unlocked, once one we will consider it open, so this will become 4, this will become 2, and one we will consider it close. So close means 3 become 2, so we have already 2, and 1 becomes 0, so we have a 0. As you can see, we have 4 opens, 2 opens, and a 0 and a empty string. And if we have a 0 here, we will return true. So now talking about the time complexity is still same. So we have n square, we have space complexity we have only n, we have eliminated this square. So we have optimized something, right? Now guys, as you can see in the whole example, right, in the whole example, as you can see that we always have a range which start with something, which end on something, and in between there are some integers. So can you so do you remember the pattern? So if you remember, or you can go back in the video, it is always like 0 plus 0 2 4 6 something, or 1 3 5 7 something. You can see, you can check. Or also in the different example it will like minus 1 1 3 5 something, right? But we will for minus 1 cases we will ignore those cases. So that's all. So guys, this is the pattern which we can see in the set of integers, right? So what we can do is we so now we have a so we have an example. What we can do is, instead of making this set, right, we can make a starting integer, ending integer, right? Because starting the range and ending the range. So in the very first we have 0 integers, so we have started with 0, ended with 0, and while traversing on this, so if so this is I can say the most optimized solution. This is 100% beat. Nice. Okay, so we are starting with something. We have started at 0, ended at 0, right? And if the character, if first we have to check the lock. If the lock is 0, right, we will make starting minus equals to 1 and ending plus equals to 1, because as we can see at the lock, so here we have plus 2, here we have plus 2, and at the unlock character we have, so we can make it a open parenthesis with we get plus 3, we can make it a close parenthesis, so we will make a plus 1. So starting, so we have a starting with so we have a range, we got a range with plus 1 to plus 3, right? So we will decrease the starting of the range and we will increase the ending of the range. Okay, else if we got a character which is open parenthesis, so we will make starting plus equals to 1, ending plus equals to 1. So okay, so if we got a character which is open parenthesis, we can say we have a range which is started at 1 and ended at 1, right? And else if we got a character which is closed parenthesis, we can say we can started we can decrease our starting range and we can decrease our range from both the ends, right? Okay, so now check, this is our case, this is the both are locked, so this condition is get bypassed, and both are open parentheses, so we have starting got plus 2, so starting equals to 2 and ending equals to 2, right? Now we have a lock here, we have a unlocked character here, so starting got reduced by 1 and ending got increased by 1. Okay, we got a two locked character, which is first is a closed parenthesis and then is a open parenthesis. So again by closing we will make it as 0 and 2, and by opening it again we will make it 1 and 3, so the range become 1 and 3 again. And guys, this range has alternate character, right? So for ranging in 1 to 7, it will like 1 3 5 7, not 1 2 3 4 5 6 7, right? So it is like 1 3 5 7 or 0 2 4 6, as I have told earlier, right? Okay. So starting at 1 0 at 3, we got till here na, and the last character is 0, so unlocked character, which will make decreased our range and increased our ending point. So by seeing this we can say the range is all the characters are 0 to 4, and we can verify it again. So this is 0 to 4. So guys, we got something, and we got to know that we have started at 0, right? So answer is true. As simple as that. We got some check here. If ending got below 0 somewhere, we will return false. We will return return false, and if starting will become -1, we got starting as 1. So there are some checks here, because if ending got below 0, that means our whole range got less than 0, which means we got too many closed parentheses, which will make our string unbalanced. Okay, so that means this check is right. And if we got anything any start below 0, so that means that those cases are unwanted, because we don't want those cases in our example, because that already made the parenthesis unbalanced. So that means we will ignore those cases, and we know that our range is like discrete range, alternate range. So that means we will start from 1 again, we cannot start from 0. Okay, because this is a discrete range. Okay, So talking about the time complexity, so by looking at this example, we can say that we have to iterate it over one time only. So this is on type of time complexity. Space complexity is again o1, because we don't have to store anything, we have only two variables here. Okay guys, so as you can see, by just observing and optimizing our solution more and more, where we got like we have a starting time complexity of this is a heavy time complexity. This is a worst time complexity, right? To this is a kind of a solution which we can try, but as you can see, this is a requirement, this is a constraint, so this is also unacceptable. But still, from this to this is still a very good type of time complexity and space complexity. Now just we have just reduced the space complexity, which is also a very good thing. But from this n square and n to this is a very good type of a solution, and I can assure that you cannot find this solution anywhere else in all the submissions, because this I have to think a lot about this. Okay, so let's code this. So we have a starting point at 0, we have an ending at 0. So for I in range length of s, okay. So for length of s, if we have to check if locked I is equals to 0. So we will starting -1, ending +1. Okay, L if si is a open parenthesis, so we will increase starting, ending, else the only case is the string I is close parenthesis, in which we will make starting -1, ending -1. In any case, in between ending become less than 0, so we will return false. Okay, in any case, in between starting become -1, we will make starting +1. Okay, so this is all guys. So if starting is equals to 0, return true, tr return false. Okay, so okay, sorry guys, this is st. So all the cases getting passed. Let's submit this. So guys, as you can see, we got 100% time beat in time complexity and 73% beat in space complexity. Although we are using only O1 of space, still this is showing 73%, which is okay, which is fine. We know that we have a best solution ever in the best solution for this test case. I hope you got something from this video. This is a very I think I have worked a lot on this solution for providing you the best optimized case here. Thank you for your patience. I hope you learn something from this. I hope you understand how to solve the problem in the best optimized solution. If you have any doubt, you can ask me in the comment section. I will reach out to you directly. Thank you for watching this video. Thank you for your time. Thank you.